Hello, in this session we would look at a few spreadsheet examples to understand the valuation of bonds based on the concepts we've learned earlier, which is coupon rate, price of bonds and yield to maturity. What I have here for you in one spreadsheet, a lot of the theories that we have learnt in the past. Let's go over them one by one. Now if you recall, in an earlier session we looked at real interest rate plus expected inflation is equal to nominal interest rates. This is what was the Fisher equation. We have now added this concept of a risk premium. The real interest rate is 3%, the expected inflation rate is 5%, and therefore the nominal interest rate, which is a sum of the real interest rate and expected inflation, will give you a figure of 8%. Now remember, this is the government issuing the bonds. A government in any financial market in a country is the most risk-free borrower, and therefore the risk premium is 0. And therefore the yield to maturity of this security issued by the government of that country is 8%. Now what this figure shows you all over the way up to 10 years is the price of the bond and the future cash flows computed as in the day the bond is issued. The face value of the bond is 100, coupon rate is 8%, yield to maturity is also 8% on that day. The two are equal. If you do a calculation using the bond pricing theorem, you will find that the price of the bond is equal to the face value of the bond, which is 100. Let's say a year has elapsed. What would then happen is whoever is the holder of the bond would have received 8 units at the end of the first year, and therefore the first year's cash flow is gone. The residual maturity of this bond therefore now is 9 years. If nothing changed and the yield to maturity is the same as the coupon rate, the price of the bond would still be 100. However, let us say in the 1 year that has elapsed, inflation in that country has gone up from 5% to 6%. So that would mean YTM is the only one that changes. So now what does this do to the price of the bond? If you notice what's given in the red, it was earlier 100, now it's become 94. Now how do we interpret this? Today, if a bond is issued by the government, it would have to pay 9%. Now I, the investor in the original bond, I'm getting an 8% yield. Now I'm getting an 8% yield. Today's yield is 9%. Therefore if I were to sell the bonds, I should sell it at a discount, and that discount is what is computed here as 94. Now as you can see, this 94 is nothing but the sum of all of this, which is the present value of the future cash flows of that bond. The numerator is still 8%, which is the coupon. The denominator now is 9%, which is the yield to maturity. And why did the YTM change when compared to the coupon rate which existed 1 year ago? It's because the expected inflation in that country has gone up by 1%. Similarly, let's take a case where 1 more year has gone by. Residual maturity now is 8 years, and by this time the company's economic circumstances improved and the inflation rate now is, let's say, 4%. Now that means the YTM would now be 7%. And what this does to the price of the bond? Because the YTM is lower than the coupon is 8%, YTM is 7%, the bond now trades at a premium. So if you are a clever bond trader, you would have bought the bonds the previous year at 94 when the YTM was 9%, and you sell the bond when the YTM goes down to 7%. In 1 year you have made a trading profit by buying the bond when it was 94, by selling the bond when it's 105. This is in addition to the 8% coupon that you would get because you held the bond for 1 year. There are several complexities about the time at which you sell the bond. The example that we saw earlier was with respect to a government security, that means a bond issued by the government. Now I'm going to show you an example of bonds issued by companies. The first company that's in the top half of this spreadsheet is a low risk company, and there's a high risk company. Now what's the difference between a low risk company and a high risk company? In a parlance that we all understand, perhaps a low risk company is a AAA rated borrower. That means the credit rating agencies have given them the lowest level of risk or the highest rating possible, which is AAA. And a high risk company would probably have a BB or a BBB rating. In other words, it is more risky than the low risk company. Where does this difference in risk manifest itself? As you can see, it's in the risk premium. In the case of the low risk company, the risk premium is 1%. In the case of the high risk company, the risk premium is 3%. What does this do as far as the bond price of the two companies are concerned? The coupon rate at the time the bond was issued by this company is 3%, as we saw in the case of the government bond. 3% is the real interest rate, 5% is the expected inflation, and 1% is the risk premium. So the coupon equal to the YTM at the time the bond was issued in the case of the low risk company would be 9%. On the other hand, the high risk company, the coupon would be the same, 3 plus 5, 8, plus the risk premium of 3%. So the coupon and the yield for this company at the time the bond is issued would be 11%, which is 2% more than the low risk company. That's the risk premium. Let's say 1 year gone, the cash flow of 8 was received. Here too, let me say 1 year is gone. The cash flow of 8 is received. Interest rates haven't changed. That means at the end of 1 year, YTM equal to the coupon, the price of the bond would still be 100. On the other hand, let's say inflation went up to 6%. Now that would be applicable to both the bonds. So this is 6% and this too is 6%. So the price of the bond, as you can notice for the 10-year bond here, is 94.24. Now the YTM has gone up by 1% from 9% to 10%, and therefore the price of the bond, as we saw earlier, has fallen to 94. And in the case of the high risk company, the price has fallen from 100 to 94.67. Let us say, in addition to the inflation going up, which is systemic and would therefore impact both the bonds, the high risk company's risk profile has gone up even more. In other words, it has become a more risky company. That means its risk premium now is gone to, let's say, 5%. In other words, high risk company where to issue a bond today, it would have to pay a coupon of 14%. The low risk company, on the other hand, if it issued a bond today, it would have to pay a coupon of 10%. Now what does this do to the price of the bond? Here it's 94 and here it is 85. In other words, the price of the bond for the high risk company has dropped substantially more than that for the low risk company, because the YTM has gone up from 11%, which is what it was at the time the bond was issued, to 14%, contributed by 1% because of expected inflation or increase in inflation, and 2% because the risk profile of the company has gone up. Whereas in the case of the low risk company, the risk remains the same, therefore the risk premium remains the same. So the only impact on the bond price would be the change in the inflation rate, which is 1%. So you will find that it has gone up from 9% to 10%. YTM is 10%, coupon 9%. In the case of the high risk company, coupon 11%, YTM 14%. I hope the distinction between the systemic change in interest rates caused by real interest rates and expected inflation and the change in the bond price as a result of the change in the risk profile of the firms is well understood through this example.